since we have been observing Io for 20 some odd years now, Io has been constantly covered in a series of volcanic eruptions, which is what this thing is. These things go 200 miles into space. There's some violent eruptions, and it's not just one, it's a series of these, like over a dozen. And when one stops, another one starts elsewhere. These have been continuous for as long as we've been observing the moon. The problem is Io is tiny, and it's also 4.5 billion years old, right? So it should have been cooled off a long time ago, the whole old, cold, and dead principle. Io shouldn't be geologically active, but apparently it is. Its neighbor is a moon called Europa. Europa is the smoothest body in the solar system. It's mostly covered with ice. You'll hear lots of reports in the news, excited reports that there may be water under this ice. And of course, where there's water, there's life, and where there's life, there's aliens, and they're more evolved than we are, right, or whatever. Io has some interesting looking terrain here. As you see, these are cracks in the ice surface. Right next door to Europa, though, now I just said Europa was the smoothest body in the solar system. Right next door is the most heavily cratered object in the solar system, Callisto. Now, if these things formed at the same time in the same place in the same materials and the same processes, they should be roughly the same. But they ain't. And you can't blame it on different compositions either, because both moons are roughly one-half ice. Also, Europa has a core where Callisto apparently doesn't. These two objects are very dissimilar from each other. Then there's Ganymede, which is larger than the planet Mercury, actually. Ganymede is covered with this weird grooved terrain. All these grooves all over the surface, with the occasional thing where someone took a paintbrush or something and smoothed it all out. Here's a broader view of that. Bizarre stuff on the surface of Ganymede. I'm not saying I have an explanation, by the way. I'm just saying they don't. They'll talk about tectonics and so on. Oh, and by the way, Ganymede also has a magnetic field that shouldn't be there. Other moons cause problems too, like Amalthea is a little tiny one right in close to Jupiter. Jupiter's moon supposedly formed out of its own local cloud of gas and dust, which would make Amalthea a rock, but instead it's an ice ball. It's the opposite of what it was supposed to have been. And we could spend a lot more time on Jupiter's moons, but time is limited. Just remember what you're not being told about Jupiter. It can't be spinning as fast as it is. It can't be made up of what it's made up of. Io appears to be young. Ganymede can't have a magnetic field, and the moons cause other problems as well. Are you seeing a trend here yet? Is there, good news for evolution, any of this? Next up from Jupiter is Saturn. Now, of course, Saturn has the famous rings. This is the planet most people think of when you think of astronomy or a planet. Now that we have the Cassini space probe around Saturn, we've got some beautiful pictures of the structure. The rings look like they're just one big object from here with maybe this stripe in the middle, but it turns out there's actually millions of these things. Each one is its own little ring, and the ring is composed mostly of little chunks of rock and ice. There's a few moons scattered in there too and a few boulders, but mostly it's very tiny material, all orbiting around Saturn all together. And each of these has its own name, and some astronomers specialize only in studying this stuff. But, oops. One of the problems, though, is that these rings are apparently young. By young, I mean not billions of years old. Evolution says, after all this time, we're still not sure about the origin of Saturn's rings. Astronomers once thought that Saturn's rings formed when Saturn did 4.8 billion years ago, as the sun and planets coalesced from a swirling cloud of interstellar gas. But lately, he says, there's a growing awareness that Saturn's rings can't be so old. Here's why. The rings are bright and shiny, obviously, we just saw in that picture, but they sweep up space dust as Saturn goes around the sun. This space dust would darken those rings after just a few 100 million years. The fact that they're still bright and shiny tells us that the few 100 million years hasn't happened. There's also the fact that the moons outside the rings and ring material are exchanging angular momentum, basically one slowing down, one speeding up. Eventually the moons will actually be flung away from Saturn while the outer half of the rings will fall toward the planet. That doesn't happen in very long of a time either, so since it hasn't happened yet, again, the rings must be young. But we know Saturn is old. So where do these young rings come from? Anyone want to guess? Right. You're all getting the hang of this now. Christian speculates that some hundreds of millions of years ago, a time when the earliest dinosaurs roamed our planet, Saturn had no bright rings. Then, he says, something unlikely happened. A moon-sized object from the outer solar system might have flown nearby Saturn, where tidal forces ripped it apart, or maybe an asteroid smashed into one of Saturn's existing moons. The debris encircled the planet and formed the rings we see today, etc. The rings have other things that are really puzzling. You see these lines going on here. The rings have spokes. Now, keep in mind, these aren't rings. This is just chunks of material all orbiting Saturn at the same time. Why would it have spokes? Some of them are braided. No one predicted this. Imagine this. I mean, the rings are braided. Weird stuff. It's almost like a creator created this so we could scratch our chins and say, nah. Recently, when we were looking at the rings, we noticed something else with one of Saturn's moons. This is Enceladus, and the screen really does not do this picture justice. I think the lights are too bright here. Is there a way we can turn some of the lights down, or is it too late for that, probably? That helps a little bit. Yeah, there we go. So here is a moon called Enceladus. Notice this thing on the bottom of it. When we take a close-up picture of Enceladus, we see this. It's a pretty moon all by itself. But the interesting thing happens when you take a picture of it from behind, where the sun is on the other side of it from where you are, because then you see that Enceladus has geysers shooting off of it. The moon looks basically like a deflating water balloon. You open a water balloon and squeeze, and the water squirts out. That's what this thing looks like. In fact, when you process the image a little bit more to see how big these geysers are, you see they're quite substantial. In fact, there's been some other weird stuff going on with Saturn's rings that they think the material is coming from Enceladus and being added to certain of Saturn's rings, causing some of the changes we've seen. The problem is, Enceladus is far too old to be doing this. It should not be geologically active anymore. Maybe it's not old? Nah. Now, you can say, well, maybe there's some sort of inherent characteristic to the moons that would have it do this. Well, its next-door neighbor is the same size, Mimas, and not doing this kind of thing at all. This is sometimes called the Death Star moon, by the way, as you can probably guess, by this big impact crater. Something walloped it pretty hard and caused that crater. But my point is, Mimas and Enceladus, same size, one is doing very different things than the other one. Then there's Titan, another moon of Saturn, which, as you can see by the fuzziness, has an atmosphere. Now, Titan's atmosphere was mostly made up of methane, and when the Cassini probe arrived, scientists were excited to go study this moon finally and figure out some of our theories about the atmosphere were true. The problem with having a methane atmosphere, if you're billions of years old, is that methane is broken down by sunlight. So Titan's atmosphere can't last very long. It gets broken down quickly. Therefore, the prevailing theories were that Titan has seas of methane all over it to constantly replenish this methane atmosphere. The problem is when we got there and actually started poking around beneath the clouds, there ain't no such thing. So evolutionists expected to find seas of methane on the moon, and they are not there. So that atmosphere should not be methane after all these billions of years. Then there's the crowning touch. Two of Saturn's moons dance. What do I mean by dance? These two pieces of rock that you're looking at orbit Saturn very close to each other. A few tens of miles apart are their orbits. One is bigger than the other, as you can see. But my point is, one of these is further away from Saturn than the other one is, and every so often they swap roles. The one that's in the outer orbit moves to the inward orbit, and the one that's in the inward orbit moves to the outward one. And then they orbit Saturn like that way for a while, and then they swap again. Dancing moons. Neat stuff. So here's what you aren't being told about Saturn. The rings are young, Enceladus is young, Titan is young. There's dancing moons, there's weird stuff going on in the rings. It seems to me the Creator is not only skilled, but He appreciates beauty. Next out from Saturn is Uranus. Now, I wish I had a nicer picture to show you, but we don't have any. Uranus is a fairly featureless ball of blue-green, which is why it was interesting when we first got close enough from the Voyager spacecraft to start taking some measurements, and we got a surprise. First of all, Uranus has some